Welcome to my video over circles, arcs, areas of circles, and sector area. We're going to start these notes off by going over our angles and our arcs, as well as talking about some vocabulary you need to know for this unit. We have an angle whose vertex is going to be at the center of a circle, is going to be called a central angle. So, for example, here we have our angle ACB is going to be our central angle. And a central angle is going to separate the circle into two arcs. You'll have what's called a major arc and a minor arc. Okay, so think about things you know about with major and minor. You've got major and minor accidents, major and minor baseball. And so you know that that major is going to be bigger. So it will be greater than 180. And our minor is going to be less than, so it will be smaller than that 180. In the circle at the left, okay, I have my angle ACB is going to be my central angle. We have points A and B, and all of the points on the interior of that angle are going to form our minor arc. And we can call that arc AB. So to clarify here, we're looking at our endpoints of where that central angle landed on the circle. And then everything in between is what's forming our minor arc. To clarify, when we name a central angle, we are going to be using the angle that is less than 180. And so that's how I know that the smaller side right here is the interior of it and not the larger side. Now, you do have two ways of how you can name a minor arc. You've got the two letters, and so those should just be your endpoints on the arc. Or you can use three letters. You've got your endpoints, the first and the last one. And then you'll have one point on the arc that is going to be between those two endpoints. So, for example, here you could call this arc AEB as well. We have points A and B, and all of the points on the exterior of that angle ACB are going to form our major arc. And you can call this major arc ADB or arc AFB. Okay, so noticing that as I make my way around, starting at that A, all the way to that B for that major part, here you're coming across either you've got that point D, all the way to that point B, or I also did come across that F. Key thing, even though there's 2 points in between that A and B, make sure you're only using one. All right, so moving on to that, we do have that you will use, and I obviously kind of went over this, your 3 points to name a major arc. And so here I'm going to highlight, we got to use your 3 letters with the 2 as your endpoints and then the 1 in between. Moving into our semicircle. We have a semicircle is going to be formed when your endpoints are going to be endpoints that are also on the diameter. To clarify, you know it's a diameter if it's going through the center. To name a semicircle, once again, you must use 3 letters to name. And to clarify in this picture here, arc ADF and arc ABF are different semicircles, even though they'll have the same endpoints. Now, I did already kind of mention this part, but a minor arc is smaller than a semicircle, and a major arc is going to be greater than a semicircle. You can use central angles to find both the degree measure and the length of the arc. The degree measure of your arc is going to be equal to the degree measure of your central angle. And that is going to intercept that arc. So here they are giving you an example stating that if I look over here at my central angle, and if I know that this is 58 degrees, then I know that any arc that is being intercepted, okay, so here that AB, or even here we have that GH for the smaller circle, those two arc measures should be the same. They'll be 58 degrees. All right, before we move into this next section real quick, mentioning we have what is the degree measure of a semicircle. Well, half of a circle is a semicircle, and so therefore half of 360 will give you 180 degrees. All right, now we're going to move into our section over our arc length and sector area of a circle. So we are going to say that we're going to let M be the measure of your central angle. We are going to use R as our radius, which you should be familiar with, and D as diameter. So starting off, you should already know this. We have our circumference of a circle is going to be pi times your diameter. So two ways of writing that formula. We'll have our pi times d, the diameter, or we'll have 2 pi r. 2 times my radius should give you your diameter. Okay, so remember circumference is going to be, in a sense, that perimeter all the way around the circle. Well, arc length is just going to be a portion of that, okay? But to clarify, arc length is going to, and I'm going to use here this arc they are giving you, AB. It's going to be from A all the way to that B. It's the length of this curve of the circle. So the length of an arc in a circle is going to be the product, we're going to multiply, of the ratio M, how much of that of that circle we're using degree-wise, over 360, the whole circle. And the circumference of the circle, so 2 pi r. So plugging in, we will have that M over 360 times my 2 pi r. So you can rewrite this to where you are multiplying that into the numerator. So M 2 pi r over 360. Or you can even then simplify, and you would get that 2 and that 360 can simplify to 1 over 180. And so I'll have M pi r divided by 180. Okay, or you can always use proportions. Okay, so I'm going to write or, and I'm going to write this out, the proportions you can use. So we'll still have that ratio, that M over 360. But this time we're going to set it equal to the arc length that I'm trying to find, which you commonly use S for, divided by my circumference, 2 pi r. Okay, so I will just mention, and I'll show you when I get to them, how to use both of them. But this one here, I usually will just use this when I am solving for arc length. This one is super helpful when they give you arc length and you're trying to find the measure of the angle or even your radius. All right, moving into our next one, we have our area of a circle. Well, the area of a circle is just going to be the product of pi and the square of the radius. So area equals pi r squared. Then we have the area of a sector of a circle. The area of a sector of a circle is going to be the product of the ratio, so that M over 360 again, and the area of a circle. So we'll have that M over 360 times pi r squared. Once again, you can rewrite this so that it's in the numerator, my M pi r squared divided by 360. Or once again, like the arc length, we could set up proportions here. by using that m over 360 is equal to my sector area divided by my area of the full circle, pi r squared. Okay, and just to clarify, area of a sector, so area, is going to be the inside of it. So for here, it would just be a section. So we have that AOB, which be, for example, this section here, you would be finding the area of. All right, now let's move into our first practice problem. We have in circle C, the measure of my angle ICR. Okay, so looking here, that ICR is going to be this angle would be 3x plus 5. And the measure of my angle RCL would be that x minus 1. We are trying to find the measure of our arc, and we'll start at that I. We then need to go towards the L before the R. Okay, so I'm going to go I to my L, and then from there, I'm going to go up to that R. Okay, so use the order in which they are providing you with that arc to follow around to figure out what they want. Okay, so looking at this here, the one thing I do want to mention is a lot of times things are not drawn to scale. To clarify, I am not going to draw a straight line or what looks like to be a straight line and say that it's not 180. Okay, but, for example here, and you'll see when we solve, this angle, when we plug in, will actually end up being smaller than this one, but you wouldn't know that by the picture, and that's what I mean. Okay, so it's not drawn to scale, but to clarify once again, a straight line will be, yes, a straight line, okay? And therefore, if it goes through the center, you know that that will be 180. All right, so here, if I'm trying to find the measure of that arc, okay, I notice, as I kind of mentioned, that this right here is going to be 180 degrees because it's a semicircle. But I need to figure out what is x so that I can find the remainder part of it, that x minus 1. So I'm going to set up an equation using the fact that 3x plus 5 and x minus 1 are forming a straight line, and they should be equal to 180. Okay, remember you always want to set up your initial, and from that you can then start simplifying, combining your like terms. So when I combine like terms, I'm going to get 4x plus 4 is equal to 180. I'm subtracting that 4 to get that my 4x, is going to equal to 176. And when I divide, I should be left with x is equal to 44. Okay, so now that I know that my x is 44, I can take it and plug it in for that x minus 1. So 44 minus 1 is going to give me 43 degrees. So I then turn around and just add that to the 180. And I'm going to get 223 degrees for the measure of that arc. To clarify, there's a few other ways you could go about finding that. That was what stood out to me. You could also have plugged in here to this 3x plus 5, found this angle, and then just subtracted it from 360 since you don't actually want this portion of it. All right, let's go ahead and move on to the back side. We have number 2 here. In circle S, we have that the measure of my angle TSR, so here TSR is going to be this angle, is 42 degrees. We are trying to determine whether each arc is a minor, major, or semicircle. Then find the degree measure of each arc. Okay, so here we have starting off the measure of arc TRE. So I'm going to start at T. I'm going to make my way towards that R before I get to E. Well, I noticed that the line here that is formed from my two endpoints of that arc is a diameter since it goes through the center, S. To clarify, going back over here, when they name a circle, you name it by the center. And so that's how I know that S is the center of the circle. Okay, and therefore I know that this answer, without having to do any more math, is going to be 180 degrees. It's a semicircle. Okay, moving on to, we have the measure of my arc, TK. So starting at T, I'm going to go towards that K. And right off the bat, I already know that this is going to be a minor arc since they only used the two letters to name it. But now I need to figure out what the measure of it is. Okay, as I mentioned earlier, TE was a diameter because it went through the center S. RK is also going to be a diameter. And so since we know part of it is going to be 42, I can subtract that 42 from my 180. And I'll be left with 138 degrees. All right, moving into the last part of this problem. We're going to have here our measure of arc T. So starting here at T, making my way towards that R. Okay, and then picking up and finishing off till I get to that K. Okay, so looking at that, I'll be able to determine that that is a major arc. And to find the measure of it, I noticed that I passed over that diameter here, but I know that that whole side is going to be 180. And therefore, I can use my vertical angles to say that this section here is 42 degrees. So I can add 180 plus the 42 degrees, and I'll get 222 degrees. All right, now moving into our next one, number 3. They are asking us to find the length of our arc ADB. Okay, so I'm going to start here at A, then go towards D, and then B. In circle M in terms of pi. Okay, so right off the bat, I notice here that they are giving me 150 degrees for the minor arc. Okay, and so I need to find my major arcs, M. Well, I can use the fact that the whole circle is 360, and I'm going to subtract that 150 and see what I'm left with. So I'm going to get 210 degrees here. All right, so plugging into my formula here, I would have that M pi r over my 180. Okay, and so I'm going to substitute in my M is that 110. Pi times my radius of 18 divided by 180. Okay, so here's my initial. I'm going to work through and simplify a little bit. And so here I notice that in my numerator, I have that 210, and my denominator has that 180. And those are both going to be divisible by 10. So I can rewrite this as 21 pi times that 18 divided by 180. Well, here, what's very helpful is the fact that I do have that 18 up top and in my denominator. So I can cancel those two out, and I'm left with only 21 pi. Now, since we are finding the length of this arc, I need to include my units of that centimeters that was given with my radius. So 21 pi centimeters. Now, for my kids that are enrolled in my class, the one thing I want to mention is here, I did cross out, but please do not do that in your initial. Okay, so you can rewrite it, you can simplify a little bit, or just rewrite the whole thing, and then you can cross out and start simplifying. But I need to see the initial without anything done to it. Now, the next thing I want to mention is that I know here that my answer is not a degree. It's not that 210 degrees because they are asking for one, the length of my arc. Two, I do have that in terms of pi. And the fact that here that arc ADB does not have that M in front of it. Okay, to clarify, if they had said, I'm going to write it for you, we got the measure of arc ADB like this, that would be the degrees because of that M in front of the name. Okay, so here I know I'm plugging into the arc length formula because of the two things I kind of showed, as well as here without that M in front, I should be giving the length, not the degrees. Okay, and I'll set up and solve for you or show you a little bit of how you get started to solve using the proportions. Okay, if you're using that proportion, you would have that M, so that 210 over my 360 would be equal to the arc length. So I'm going to use that S, which you won't have to define once again because it is a commonly used variable for arc length, over my 2 pi and then my radius of that 18. Then what I can do here is I can cross multiply. Okay, and so cross multiplying, I'm going to get that 210 times my 2 pi 18 will be equal to my 360 times my S arc length. Then I'm just going to divide so that I can solve for that S. And you'll see here, now I'm ending up with exactly what I had up here. I just had this simplified one here. Okay, so this is another option. Like I said, I really only like to use the proportion one when I'm solving for R, my radius, or my angle measure or arc measure, and I'm given my arc length. But it's completely up to you. All right, now let's move into the next one. We have number 4, find the area of my sector. And we have given to us that ACB. All right, so that's going to be this sector here. ACB is this section. So we're going to find the area of this sector. And we know that my M is going to be that 100 degrees. Okay, so to clarify, let me write my formula. We got that M pi R squared over 360. Okay, so using my substitution, I know that my M, like I said, is that 100 degrees times pi, and then my R is that 6 squared divided by my 360. Okay, I'm just plugging into my initial. Then I'm going to simplify a little bit. So I'm going to rewrite. Once again, I do see that 100 and that 360 are both divisible by 10. So I'll get 10 pi, I'm going to square that 6, to get 36. All divided by that 36 I got when I divided by 10. Okay, now this doesn't always happen. Obviously, I've now shown 2 examples where it did, but it doesn't always. But I do notice here, I do have that 36 in the numerator and denominator. So I can cancel those 2 out, and I'll be left with my 10 pi. And making sure that we do include our units because we are dealing with that area. So I'm going to have my meters squared. Okay, and so that's how I get my answer. Once again, please do not cross off like I did here in the initial. You need to plug in. Okay, even here with this r squared, I need to see 6 squared before you get that 36. Okay, like I did in the previous one, I'm going to show you just me kind of starting it off. I'm not going to go through and solve because you'll see why. But plugging in, if you wanted to use your proportions, you would have that 100 over 360 is going to be equal to my sector area divided by my area of a circle, pi r squared. Okay, once again, I can cross multiply here, and I'm going to get that 100 pi 6 squared is going to be equal to my 360 times the sector area. Then I'm dividing by that 360. And so I'm able to cancel out here with the 2 360s to be left with just my sector area. And once again, you'll notice that I am going to get exactly what I started off with over here, which is why I tend to not use the proportions when I'm solving for sector area. I usually, once again, will do it if I'm finding my m or my radius. All right, let's move into our last section, and we have a problem to go with it. So area of a segment, we have, depending on what information you are given, you can find the area of a segment of a circle by, we'll have our area of our segment is equal to the area of the sector minus the area of the triangle. Okay, so I'm going to show you with this circle in the problem below. Okay, I'm starting off with the area of this whole sector here. Okay, that's what I'm going to start off by finding. And then in order to find the segment area, I am going to be subtracting, taking away the area of this triangle. And then you'll notice that all I'm left with is the area, the shaded part, of what is after that segment. All right, so let's begin with the area of our sector. So the area of our sector, we're going to use that m, so 120 pi. We have our radius, which is that 24 squared over 360. Okay, just working through and simplifying a little bit, I'll have that 120 and that 360 will reduce to 1/3. So I'll have pi 24 squared over 3. Now, what I want to say here is I would not leave this as 24 squared, okay? Because to clarify here, for some of you, you're going to see that 24, your 3, and you're going to say 24 divided by 3 is going to give you 8 squared. But that's not the case. So what I'm going to do is I'm going to expand out what I have, which is that pi times 24 times 24 divided by 3. So when you are simplifying your fraction here, and it's multiplication in the numerator, what you are doing is you are just picking one of those numbers in the numerator and in the denominator and dividing, okay, or simplifying. So here that 24 and that 3, 24 divided by 3 will leave me with 8. And so I'm left with that 8 times 24, which will give me 192 pi, and then we'll have our feet squared. So that's the area of my sector. Now let's move into the area of my triangle. So think back, we know that area of a triangle is going to be 1/2 the base of the triangle times the height of the triangle. Okay, so I'm going to draw here for you a triangle. And we know that this angle here is going to be that 120 degrees. I also know that this is an isosceles triangle. And I know this because from O to B, it's a radius. And from O to that A is also a radius, and therefore they are the same. And you have two congruent sides, you have an isosceles triangle. Now, if you think back, we know that when I have that isosceles triangle and I draw an altitude, the height, that it is going to bisect that top angle, and I'm going to be left with a 60 degrees here, a 30, and then we have that 90. So unfortunately, I remember the groans in class, we are bringing back our 30, 60, 90, and we're going to use those ratios to solve. Okay, so we know that the side opposite of my 30 should be my S. Opposite of my 90, the hypotenuse, is 2S, which we happen to know is equal to that 24. And then my half my base is that S root 3, since it's not touching the 60 degree angle. Okay, and so to clarify, since I want the base of the triangle, this would be 2S root 3. Okay, because I'll have two of them, this and this will be congruent. All right, so since I know that 2S is equal to 24, I can say that my S is going to be equal to 12. And then plugging in down here, my 2S root 3, my base, will be equal to that 24 root 3. Okay, so with that being said, I'm going to come back over here to my area formula. We have 1/2 my base, which we said is that 2S root 3, so 24 root 3, times my height, which was that altitude S, which we said was 12. Okay, so simplifying here, I have 1/2 of 24 is going to give me 12. So I'll have 12 root 3 times that 12. 12 times 12 will give me 144. And I'll have that root 3 feet squared. Okay, so with that being said, the area of my segment, remember they said is just us going to subtract the area of the sector. We've got that 192 pi minus the triangle, that 144 root 3. And then we'll have our units, which is that feet squared. And since we have that pi in the first one and also the root 3 in the second one, we cannot actually subtract any further. This would be my final answer.